Today I'm going to show you how to run a one-way ANOVA and interpret it in SPSS. Now I'm going to use house and percentage of battles won. This data is made up data from that has a Harry Potter theme. So any Harry Potter fans out there would know what house meant, but I'm going to go to variable view to show you that houses, I have the values of the houses. 1 stands for Gryffindor, 2 Ravenclaw, 3 Slytherin, and 4 Hufflepuff. Now here you can see that this person is Gryffindor, this person is Ravenclaw, etc. And I'm interested in if the house matters when it comes to percentage of battles won. Our house would be our Ivy, and there's 4 levels because you have 4 different houses. And the percentage of battles won is the dependent variable. So first thing we need to do is check to make sure that check for normality and percentage of battles won. So we go to Analyze, Descriptive Statistics, Frequencies. We're going to take the percentage of battles won, move it over to the variable box, and we'll click Statistics, and you're checking for skewness and kurtosis. You can also check for your mean, standard deviation, just to have them. We click Continue, and we don't need frequency tables, so I'm going to uncheck that. OK. Now here we can see our mean, standard deviation, skewness at -0.414, and kurtosis at -0.918. Now, as long as these numbers are between -2 and +2, we have no issues. So we can continue with our ANOVA. So then we would go to Analyze, Compare Means, Way ANOVA, and our house will go as the factor, and our percentage of battles won will go to our dependent list. Now, since we have 4 different houses, we need to do what is called a post hoc test. A post hoc test, if we have a difference, the post hoc test will tell us where that difference is. So we're going to go to post hoc. Now LSD is the least conservative. You're going to maximize your false alarms here and minimize your misses, your type 2 errors. And with Bonferroni, that's the most conservative, so you're going to maximize your type 2 errors and minimize your false alarms or type 1 errors. So we're going to take both of those, and you can also check one of these if you have a problem with your Levine's test. This is equal variance is not assumed. We can check that as well. Now you also want to click Options, and you can check for homogeneity of variance. You can also put descriptives in there, and you'll get a descriptive box with your means and everything like that. Now we click OK, and we get this. Now this is the descriptives, the box that we checked. It gives you all your information, your means, your standard deviations. This is our test of homogeneity of variances, and if this was significant, we would have an issue. However, it's not significant. This is greater than 0.05. So since it's greater than 0.05, it is not significant, and we can continue with our ANOVA. So right here we have our ANOVA summary table that tells us our between group variances, our within group variances. The between groups will be between the houses, and our within groups is sampling error. So this is the variance within each house, like the variance in Gryffindor. So one person in Gryffindor isn't going to have the same percentage of battles won as the next. They're individual differences that we have to account for. That's called sampling error. So we look up here at our between groups and we check over to see what our significance, what our p-value is. So for our F statistic of 10.662, our p-value is, it's listed here as 0.000, but p-values cannot be 0. This is just rounded because SPSS has to make a cutoff, so 3 decimal places here is the cutoff. You can actually say that p is less than 0.001 when you see this number. So p is less than 0.001. Now, so it is significant, so you know there's a difference between the groups, but you have to figure out where the difference is. So there could be more than one difference. There might just be the one difference between two different groups. So we need to check our post hoc tests. Now, as you can see, they have them listed here. This is LSD, Bonferroni, Games Howell. So they're different ones. I want to focus on Bonferroni because that's the most conservative and it minimizes false alarms. So I'm going to go ahead and go with that. And we see that Gryffindor compared to Ravenclaw, when we look at our significance, which is this column, Gryffindor compared to Ravenclaw is not significant. So you cannot say there's significance here. Gryffindor compared to Slytherin, it's also not significant. So there's no difference that we have failed to reject the null here and here, right? There's nothing happening between those two because we probably didn't have enough data to find a difference. And Gryffindor to Hufflepuff, you can see that there is significance here because it is less than 0.05. So that's one difference. Now we can move on to see what we have for Ravenclaw. Ravenclaw, again, Gryffindor, no difference. Ravenclaw compared to the Slytherin, you have a difference there. And then Ravenclaw compared to Hufflepuff, you also have a difference. Your p-value here is p is less than 0.001. Now again, they keep comparing. I don't know why they list it like this, but they do compare them more than once. So Slytherin is compared to Gryffindor here and here, but they have the same p-values, so because it's the same comparison, they just list it more than once. So basically here we have no difference between Gryffindor and Ravenclaw. We have no difference between Gryffindor and Slytherin, but Gryffindor and Hufflepuff have a difference. And you can scroll back up to your means table. And Gryffindor had a mean of 70.9. And Hufflepuff had a mean of only 38.9. So you can say here that Gryffindor wins more battles than Hufflepuff. Gryffindor students win more battles than Hufflepuff students. Now again, you scroll down to see if there's another difference. Ravenclaw compared to Slytherin is also significant, and Ravenclaw compared to Hufflepuff is statistically significant. So we look up here, and Ravenclaw had the highest mean. So in both cases, Ravenclaw performed better than both Slytherin and Hufflepuff students. And we scroll back down to check one more time to see if there's anything else. Okay, so there's no difference between Slytherin and Hufflepuff. We've already talked about our Slytherin compared to Ravenclaw and our Hufflepuff compared to Ravenclaw. So we've made our conclusions. I hope you found this helpful. Just remember, when you're doing the ANOVA and you have, when you're doing ANOVA, you should have 3 groups or more. You should do a post hoc. You should click to do a post hoc test, because a post hoc test tells you where the differences are. You can find a difference here, but if you don't know where, it doesn't matter. I hope you found this video helpful.